welcome back to Chem with Kes. Today we are going to discuss hydrohalogenation and how to recognize a 1,2 methyl shift. So let's begin. As far as our mechanism, everything is the exact same. So you will go through the same steps, making sure you understand this is the rate determining step, and going through the motions of understanding I could have a carbocation here and I can have another one at the other carbon. You would then go through and complete both of those mechanisms in the fast rate. So that would go there to save a little bit of time. This one would travel to here, giving you your two answers that we also already know that there's more than that because I'm telling you we have to go through a methyl shift. But would you be asked to provide all of these? Yes. So just because the mechanism may have, like for instance, a hydride shift or a methyl shift, you need to show all of the possible answers that can be provided and what led you to the hydride methyl shift or later on ring expansion. So now to go through, so that right there are your two answers. But when we have to go through the methyl shift, we have to use one of the intermediates. The intermediates are located right here. Those are your carbocation intermediates. So you have to pick the one that is closest to what you're trying to do. So always recognize that your double bond is always your starting point. But if you look next door to your double bond, whether it's here or here, you will notice for every methyl shift, you will see a quaternary carbon with a methyl on it. So that is your indication. So since we see that methyl, we want to choose the closest carbocation intermediate to the methyl, which would be the one over here. So that means I need to use this intermediate in order to move forward. So that means I will take the intermediate. I will denote my my methyl shift by, you don't have to draw the methyl in, but I just prefer y'all to see it. That methyl is going to go to the positive charge. You would notate it as 1,2-Me shift. Or if you want to spell out methyl, you're more than welcome to. That ends up giving you, that ends up giving you your methyl that just got moved over to here. Then you have your ethyl over here. Now, since you moved your methyl from this location, that is where your new carbocation will go. Then you can proceed with the mechanism by attaching the Br minus. That would be your fast step, giving you this structure as your major product. Why is that major again? Because here the halogen is tertiary compared to the answers above, which are secondary. Hopefully this makes sense. And again, the best way to notice it is to see a quaternary carbon with a methyl. And where will this be? It will be close to the double bond. And that's always. So those are your little things to make sure you understand.